CROSSING is a joint effort of scientists from quantum physics, cryptography, system security, and software engineering, who collaborate in 3 interconnected project areas. In Project P4, CROSSING is doing research on quantum key hubs. Secure electronic communication is crucial to both society and the economy. Today, security is achieved with cryptography. Unfortunately, today's cryptography is inadequate. For example, the encryption algorithms used today will become insecure over time because of new, powerful algorithms and new technologies like quantum computers. This means an attacker who stores encrypted data today might be able to decrypt it in the future. A solution to this problem is offered by quantum cryptography. Its security is based on physical principles which do not have a counterpart in classical cryptography. These physical principles allow information theoretically secure encryption to be achieved. This means encryption which is unbreakable, no matter how much time and computing power are applied. To achieve this, an independent photon source creates entangled pairs of photons and splits them between the communicating parties, Alice and Bob. For each photon pair, Alice and Bob independently measure the state of their photon, producing random results of either 0 or 1. Finally, they end up with long bit strings. Next, Alice and Bob agree on the bits for which they used identical detector settings during measurement and discard the rest. The resulting bit strings are highly correlated datasets due to the quantum nature of the entangled photon pairs. To detect the presence of an attacker, Alice and Bob must now determine the quality of their correlations by publicly comparing parts of their bit strings. Any measurements of quantum objects typically change the object's state. Therefore, any attempt by an attacker to intercept and measure photons or to manipulate the photon source results in a loss of correlations. If an attacker was present, indicated by the correlations being below a certain threshold, the bit strings are discarded and Alice and Bob must start over. Otherwise, they can securely extract identical information theoretically secure keys from their bit strings. Using these keys, Alice and Bob can now securely communicate over classical data links like the Internet. The goal of Project P4 is to solve a major challenge in quantum cryptography, which is scalability. Typical quantum cryptography experiments involve only 2 parties communicating with each other. However, for practical applications, we will need to build a network enabling many participants to communicate securely. In Project P4, we intend to build a quantum key hub which can create and distribute pairs of entangled photons to multiple parties, such that any 2 parties can communicate. As a first step, we will build a hub with 4 connected parties. This is one of the fundamental stepping stones towards building scalable quantum network architectures. To learn more about quantum key hubs, please visit our website.